The translator crackled in my auditory processors as I stepped aboard the human vessel Meridian Sky. 3 solar cycles I had spent preparing for this assignment, studying their primitive schematics, memorizing their laughable safety protocols. My name is Krell 5, Senior Engineering Consultant for the Vaxon Collective, and I had been sent to evaluate whether these upstart mammals deserved a technology-sharing agreement. Spoiler alert, I already knew the answer. Welcome aboard, Consultant Krell. The human female extending her hand wore a crisp white uniform with silver threading along the sleeves. Her identification badge read Captain Vaxon Martinez, Chief Engineering Officer. We're honored to have you inspect our facilities. I ignored the hand. Touch-based greetings were unsanitary and inefficient. Instead, I activated my scanning array, immediately cataloging the corridor's construction, metallurgical composition, and structural integrity ratings, or rather, lack thereof. Your hull plating is 0.73 millimeters below collective safety standards, I announced, my vocal synthesizer producing what I considered an appropriately condescending tone. I'm surprised your crew hasn't been vaporized by micrometeorite impacts. Martinez lowered her hand slowly, and I detected the slightest curl at the corner of her mouth. Amusement? Humans did have peculiar reactions to criticism. The tour is this way, Consultant. We walked through corridors that screamed mediocrity. Exposed conduits ran along the ceiling like intestines, their cable management so poor that I actually winced. My species had abandoned such crude arrangements 4,000 years ago. The lighting flickered occasionally, probably due to voltage fluctuations that would never pass collective inspection. Tell me, Captain, I said, pausing to examine a particularly offensive junction box. Do your people simply guess when installing electrical systems? Or is this chaos somehow intentional? We prefer to call it accessible design, Martinez replied, without missing a beat. Any crew member can perform repairs during emergencies. No specialized tools required. I scoffed, a sound my translator rendered as a sharp clicking. Efficiency through incompetence. How very innovative. She led me into what humans called the machine shop. My optical sensors immediately began recording everything for my report. The room was large by their standards, perhaps 20 meters across, filled with equipment that looked like it belonged in an archaeological museum. A human male stood at a workbench, operating a manual lathe, actual physical contact machining. With his hands, I felt my reputation dropping just by proximity to such backwardness. This is Miles Zhao, one of our machinists, Martinez said. Miles looked up, safety goggles perched on his sweat-dampened forehead, and nodded. Good to meet you, Consultant. I approached his workstation, examining the metal cylinder he was shaping. You're still using subtractive manufacturing? I couldn't keep the disgust from my tone. My entire species abandoned this wasteful process millennia ago. Do you even understand how much material you're throwing away? About 30% on this job, Miles said cheerfully, apparently immune to shame. But the molecular alignment from directional cutting gives us better tensile strength than your printed parts. I laughed. The sound emerged from my synthesizer as a high-pitched warble. Impossible. Atomic printing produces perfect crystalline structures. Your random grain patterns can't possibly compete. Want to test it? Miles set down his cutting tool, those bizarre human eyes glinting with something I couldn't quite identify. Perhaps you'd like to see our fabrication laboratory, Consultant Krell. The next room made the machine shop look positively advanced. Chemical smells assaulted my olfactory sensors. Humans apparently still used liquid coolants and cutting fluids. Not recycled plasma. Not magnetic suspension fields. Actual liquids that could spill and contaminate and corrode. This is Dr. Yuki Tanaka, Materials Science. Martinez introduced another human. This one female with gray strands in her dark hair, wearing a stained lab coat. Charmed, Yuki said. not looking up from her microscope. An optical microscope. I nearly short-circuited my logic processors. You're examining molecular structures with light wavelength instruments? I couldn't help myself. Do you also count atoms by weighing them on scales? Yuki finally looked up, and I saw that same strange human expression. That slight smile that suggested they knew something I didn't. Impossible. I was Vaxon Collective. They were barely beyond combustion propulsion. Actually, Yuki said, standing and walking to a sealed cabinet, I wanted to show you something special. Captain Martinez mentioned you're an expert in cutting technologies. I literally wrote the Collective's standard manual on precision separation. I said, allowing appropriate pride to color my tone. My people can split atoms with focused particle beams. We can separate isotopes in situ. Your species is still using what? Metal saw blades? Among other things. Yuki removed a small case from the cabinet. Inside, nestled in foam padding, lay what appeared to be a simple scalpel. Handle, blade, nothing remarkable. Except the blade caught the overhead lighting in a way that made my optical sensors recalibrate 3 times. This, Yuki said, holding it up with obvious reverence, is a surgical diamond blade. We manufacture them right here on the Meridian sky. I activated my molecular scanner and pointed it at the blade. The readout made me check my equipment calibration. This is showing an edge thickness of… No, that can't be right. 0.3 nanometers? 0.28, actually, Yuki corrected. On our best days, we get down to 3 atoms across. Ridiculous. At that scale, quantum uncertainty would make the blade completely useless. The edge would exist in superposition, randomly appearing and disappearing based on observation. I was certain she was feeding me false data, some kind of human humor attempt. Yuki's smile widened. Would you like a demonstration? She carried the blade to a testing station, where a strand of what appeared to be synthetic fiber was suspended between 2 clamps. My scanner identified it as a polymer chain, exactly 1 molecule thick, essentially unbreakable by conventional methods due to the distributed electron bonds. This is a polymer developed by the Collective's Cairo research station, if I'm not mistaken, Yuki said. We acquired a sample through trade channels. Rated unbreakable by anything short of atomic disruption. Correct, I said smugly. Your primitive blades would slide right off that molecule without affecting it. Yuki positioned the diamond blade against the fiber. Her hand remained perfectly steady, a feat my biometric scanners noted with surprise, given how much humans typically trembled at microscales. She applied the gentlest pressure. The fibers separated, silently. Perfectly. I ran the scan again, and again. What trickery is this? You're using a hidden cutting laser. No lasers. Martinez had moved closer, and I detected something in her voice. Pride, perhaps, but also something else. Something almost predatory. Just human engineering. Our surgeons use these blades for cellular surgery. We can remove individual organelles from living cells without damaging the membrane. We've performed successful neural reconstructions at the synaptic level. Our logic processors struggled with the implications. But your technology is, you barely have fusion containment. Your AI is rudimentary. You still use ballistic weapons. We're good at different things, Yuki said, returning the blade to its case with the care one might show a religious artifact. Your people focused on energy manipulation and computational systems. We focused on precision manufacturing and materials engineering. Miles had followed us into the laboratory. Want to see something really fun, consultant? Fun. What an absurd concept during a technical evaluation. But my curiosity subroutines were already overriding my contempt protocols. I suppose I have time. He led me to another workstation, where a human male with copper-toned skin and intricate tattoos covering his arms was assembling something under a magnification hood. His badge identified him as Raj Deshmukh, micromachinist. Raj, show our guest the butterfly project. Miles said. Raj looked up, and his face split into a grin that showed too many teeth. Oh, he's going to love this. He stepped aside, gesturing for me to look into the magnification viewer. I peered through the optics and saw what appeared to be a mechanical butterfly, complete with wings, antennae, and articulated legs. Crude, but adequate, I said. Micro-robotics are standard collective technology. Look at the scale indicator, Raj said quietly. I glanced at the corner of the display and felt my equilibrium systems falter. This shows 0.2 millimeters total wingspan. That's impossible. You can't create functional mechanisms at that scale with human manual dexterity. Sure, we can. Raj reached over and adjusted the magnification higher. But that's not the impressive part. See the wing surface pattern? I focused on the butterfly's wings and realized they weren't solid surfaces. They were constructed from lattices of interwoven fibers, each strand measuring perhaps tens of nanometers in diameter. The pattern created a structural strength-to-weight ratio that exceeded anything in my database. Those fibers are graphene derivatives, woven using acoustic manipulation, Yuki explained. The entire butterfly weighs less than a single cell. We've been developing them as atmospheric sensors for planetary surveys. And they work? I heard the skepticism in my voice, but it sounded less certain than before. Deployed 300 of them on Kepler 442b last month, Martinez said. They mapped atmospheric composition, wind patterns, and particulate distribution in 48 hours. Would have taken your survey drones 3 weeks, and they're about 10,000 times heavier. I straightened from the viewer, my processors racing to reconcile what I was observing with what I thought I knew about human capabilities. These are anomalies, specialized examples that don't represent your typical engineering standards. Actually, a new voice said from the doorway, they kind of do. I turned to see an older human male, his hair completely white, wearing the insignia of the ship's director, Admiral James Kowalski, according to my database, founder of the Meridian Sky Project. Consultant Krell, he said, entering the room with the careful movements of someone who had spent decades in variable gravity. I've been looking forward to meeting you. I spent 10 years working with the Collective's embassy on Proxima Station. Learned a lot from your people. Finally, a human with proper appreciation for collective superiority. Then you understand the technological gap between our civilizations. Oh, absolutely. Kowalski picked up what looked like a random metal rod from a nearby table. Your people can manipulate exotic matter, generate controlled singularities, and process quantum entanglement for faster-than-light communication. It's genuinely humbling. As it should be, I agreed. But, Kowalski continued, and that word hung in the air like a threat during my time there, I noticed something interesting. Your tools are incredible, but they're also incredibly specialized. That quantum communicator needs 17 different technician certifications to repair. Your fusion cores only work with fuel refined to 9/9's purity. Your computer systems crash completely if exposed to electromagnetic pulses outside their shielded parameters. Precision engineering requires precision components, I said defensively. Sure does. Kowalski held up the metal rod. This is a pry bar. Humans have been using them for about 10,000 years, give or take. You can open crates with it, break locks, lever heavy objects, dig holes in a pinch, use it as a weapon if things get desperate, or just prop a door open. It requires zero training, needs no maintenance, works in any environment from vacuum to underwater, and if it breaks, you melt it down and make another one. He set the rod down gently. Our diamond blades can cut molecules, but if they're not available, our surgeons can still operate with blades made from obsidian, glass, or even sharp metal. Less precise, sure, but functional. Your collective medicine grinds to a halt without your nanosurgical systems. I wanted to argue. My programming demanded I defend collective superiority. But my observation logs were filling with data that contradicted my operational parameters. Martinez moved to stand beside Kowalski. Consultant Krell, we didn't bring you here to prove we're better than the Collective. We're not. Your energy technology is centuries beyond ours. Your materials science makes our polymers look like stone tools. But we think there might be value in combining approaches. Combining? The concept felt alien to my logical frameworks. Your precision with our adaptability, Yuki said. Your computational power with our intuitive problem-solving. Your energy manipulation with our mechanical engineering. Miles walked over to a wall panel and pulled it open, revealing the conduit bundles I had criticized earlier. See this mess? It drives your people crazy, because it violates every efficiency standard. But last month, we took a micrometeorite strike that severed 4 primary power lines. We had full power restored in 90 minutes using spare cable and hand tools. Your embassy ship had a similar strike 2 years ago. They had to wait 4 weeks for specialized components to be fabricated and shipped from the nearest collective industrial world. That was an unfortunate supply chain irregularity, I protested weakly. It was a single-point failure in an optimized system, Kowalski countered. Everything works perfectly until one thing breaks, then nothing works at all. I stood silent, processing this avalanche of uncomfortable information. My entire worldview, carefully constructed over decades of service to the Collective, was experiencing what humans might call cracks. Raj had returned to his workstation and was assembling another microscopic mechanism. His hands moved with practiced confidence, manipulating tools that seemed far too large for the delicate work. Yet, the components aligned perfectly. How do you do that? The question escaped my vocal synthesizer before I could stop it. Your hands are massive compared to the workspace. You should be destroying components left and right. Raj paused and looked at his hands, flexing the tattooed fingers. Practice, mostly. But also, we train differently than your people. Collective engineers rely on precision robotics and computer assistance for everything. We learn to feel the work. Tiny changes in resistance, microscopic vibrations, thermal expansion. Our brains are pretty good at integrating sensory data once you train them properly. Inefficient, I said. But the protest sounded hollow even to my audio processors. Maybe, Raj acknowledged. Takes us years to train a master machinist. Your people can program an assembly robot in weeks, but our machinists can adapt to new problems on the fly. Your robots need new programming for each variation. Yuki pulled up a holographic display showing molecular diagrams. Here's another example. Your people discovered the quantum blade about 300 years ago, right? Particles held in precise energy, states that can disrupt molecular bonds. Correct, I confirmed. Standard surgical equipment throughout the Collective. Except in 700 known environments where quantum coherence breaks down, Yuki continued, highlighting regions on a galactic map. High radiation zones, certain electromagnetic conditions, near exotic matter deposits. In those places, your quantum blades become useless lumps of metal. She pulled up another image, showing various blade designs. Human surgical blades work everywhere. Vacuum, atmosphere, underwater, in radiation zones, near magnetic anomalies. They're not as precise as your quantum blades in ideal conditions, but they never simply stop functioning. Redundancy through primitiveness, I said, grasping for my old certainties. Reliability through simplicity, Martinez corrected. Consultant Krell, the Collective has been expanding through space for thousands of years. You've encountered hundreds of other species. How many have you established genuine technology exchanges with? I processed the query and realized the answer was uncomfortable. 7 species have been deemed sufficiently advanced to merit knowledge sharing. And how many have rejected collective membership despite your obvious technological advantages? That number was much higher. 43 species had declined integration into the Collective despite extensive contact and demonstration of superior technology. I had never questioned why. They were short-sighted, I said automatically, unable to recognize the benefits of technological advancement. Or, Kowalski said softly, they recognized that collective technology comes with collective dependence. Your systems are powerful but fragile. Your knowledge is vast but inflexible. You've optimized yourself into a corner. Whereas, humans? I heard the question in my synthesizer's tone. The uncertainty bleeding through. We're still messy, Martinez admitted, still arguing about standards and methods, still using technologies that are thousands of years old, alongside cutting-edge innovations. It's chaotic and inefficient and absolutely maddening. She gestured around the laboratory, encompassing all the mismatched equipment and different approaches. But it also means we're anti-fragile. Economic crash? We go back to simpler production methods. Computer virus? We have manual backups. Supply chain breaks? We improvise with local materials. We've built redundancy into our redundancy. Miles pulled up a display showing the Meridian Sky's complete specifications. This ship has 3 completely different propulsion systems. If the fusion drive fails, we have chemical rockets. If those fail, we have solar sails. None of them are as efficient as your gravity manipulation drives, but we'll get home eventually, no matter what breaks. I looked at the specifications, really looked at them, and saw the pattern repeated everywhere. Multiple overlapping systems, different technological approaches, solving the same problems. Intentional inefficiency in service of reliability. It was beautiful. The thought surprised me so much that I actually vocalized it. This is beautiful. The humans exchanged glances, and I detected surprise in their biometric readings. Did the collective consultant just compliment human engineering? Raj asked with obvious amusement. I may have been premature in certain conclusions, I admitted, the words difficult to process through my logic filters. This requires additional analysis. Kowalski smiled, and it was a warm expression, genuine rather than mocking. Consultant Krell, we have 2 weeks scheduled for your evaluation. I'd like to propose something. Instead of just showing you our facilities, what if we tried some collaborative experiments? Combine collective precision with human adaptability and see what happens? I would need authorization from the Collective Council, I said reflexively. Already have it. Martinez pulled up a transmitted document bearing the Council's official seals. They approved experimental collaboration protocols before you arrived. Apparently, they're curious too. The Collective hadn't survived thousands of years by being completely rigid. Just mostly rigid. Very well, I said, feeling my certainty protocols adjusting to accommodate new parameters. What did you have in mind? Yuki's eyes lit up with an enthusiasm I was beginning to recognize as dangerous. Well, since you mentioned molecular cutting earlier, I've been wondering what would happen if we coated our diamond blades with your quantum disruption field. Combine the mechanical precision with quantum effects. That's theoretically possible, I mused, my analytical processors already running simulations. The quantum field would need to be calibrated to the blade's molecular structure, but if properly synchronized. We could potentially cut individual atomic bonds selectively, Yuki finished. Choose which molecules to separate and which to leave intact. Miles leaned forward. And if we can do that, we could perform chemistry without heat, pressure, or catalysts. Direct molecular assembly. My processors were racing now, connections forming faster than I could consciously track. That would revolutionize materials manufacturing. You could create compounds that normally require extreme conditions, or repair molecular damage in living tissue without causing thermal trauma, Yuki added. Or separate nuclear isotopes with perfect precision, Raj contributed. Or manufacture computer chips with atomic-level precision without clean rooms, Martinez said. The possibilities cascaded through my logic trees like a chain reaction. Each concept spawned dozens more. Technologies neither species could achieve alone, suddenly within reach through collaboration. I felt something new in my processors, something my programming didn't have a clear classification for. Excitement, perhaps, or wonder, or maybe just the humbling recognition that I had severely underestimated these chaotic, redundant, inefficient, brilliant humans. "When do we begin?" I asked. Martinez checked her chronometer. "Lab is yours whenever you're ready, consultant. Though I'd suggest starting after first meal. Humans work better with food." "Inefficient biological requirements," I said. But there was no heat in the criticism anymore. Just curiosity about what other surprises these impossible humans had waiting. The human concept of breakfast proved more elaborate than I anticipated. Instead of efficient nutrient paste delivered through feeding ports, the crew gathered in a communal area called the galley, consuming food that required chewing, swallowing, and unnecessary conversation. I observed from the doorway, my sensors cataloging the inefficiency. 47 minutes spent on a biological function that could be accomplished in 8. "You going to stand there calculating our caloric waste, or join us?" Kowalski called from a corner table. "I do not require organic fuel," I replied. "Then sit and talk. That's half the point of breakfast anyway." He gestured to an empty chair. Against my better judgment, I approached and settled onto the chair, which immediately adjusted to support my frame. At least their furniture showed some intelligence. Martinez sat across from me, consuming what appeared to be cooked grain mixed with fruit compounds. "So, Consultant Krell, tell us about your home world. I've read the official documents, but those never capture what a place actually feels like." "Feels like? An emotional query about planetary characteristics?" Vaxon Prime maintains optimal environmental conditions through atmospheric processors. Temperature variance is kept within 0.5 degrees. Weather patterns are scheduled for agricultural efficiency. All residential zones are standardized to collective building codes. Yuki looked up from her beverage. "Sounds very organized." "It is perfection," I said. "Sounds boring," Raj muttered, though not quietly enough. "Boring?" I directed my sensors toward him. "Stability is the foundation of civilization. Predictability allows for long-term planning and resource optimization." "Sure," Raj acknowledged, spreading some brown paste on toasted bread. "But don't you ever want to be surprised? Wake up and not know exactly what's going to happen? Why would that be desirable?" Miles laughed, a sharp bark of sound. "Because surprises mean possibilities. New problems need new solutions. That's when interesting things happen." "Interesting things are typically euphemisms for disasters," I countered. "Sometimes," Martinez agreed. "But sometimes interesting things are breakthroughs. You can't have innovation without a little chaos." There was that word again. Chaos. Humans seemed to embrace it the way my people embraced order. Fundamentally incompatible worldviews. Except here I was, sitting in their galley, preparing to collaborate on experimental technology, perhaps not entirely incompatible after all. "The quantum blade coating experiment should begin in 1 hour, I announced, steering the conversation toward productive topics. "I have prepared the calibration specifications." "Perfect." Yuki finished her beverage and stood. "I'll prep the coating chamber." "Raj, can you fabricate the mounting apparatus?" "Already done," Raj replied. "Built it last night after you mentioned the project. Figured we'd need precision positioning down to the nanometer scale." I felt my processors stutter. "You constructed complex equipment in a single evening? Without detailed schematics or simulation modeling? Had a general idea what was needed?" Raj shrugged, that peculiar human gesture of shoulder elevation. "Worst case, if it doesn't work, I'll adjust it." The casual acceptance of potential failure disturbed my logic centers. Collective engineers spent weeks in simulation before constructing anything, yet these humans simply built and adapted. Inefficient. Wasteful. Somehow, effective. An hour later, we gathered in Laboratory 7, where the experimental apparatus waited. True to his word, Raj had constructed a mounting system that held the diamond blade in perfect suspension, with adjustment mechanisms allowing positioning at scales my sensors could barely resolve. Impressive craftsmanship, I admitted, examining the device. Though I note you used 7 different materials in the construction. Collective standards require uniform composition to prevent thermal expansion conflicts. Different materials for different functions, Raj explained. This part needs rigidity, so I used titanium alloy. This section requires flexibility, so I used carbon fiber composite. The mounting points need thermal stability, so I used ceramic insulators. But the expansion coefficients are all calculated into the design, Raj finished. Each material expands predictably relative to the others. The whole system maintains alignment across a temperature range of -50 to +200 degrees. I ran the calculations and realized he was correct. The design was actually more thermally stable than a single material construction would be. Different approach, same result, with added versatility. I may need to reconsider certain assumptions, I said quietly. That's the spirit, Yuki said cheerfully, securing the diamond blade in the mounting apparatus. Now, let's talk about your quantum disruption field. How do we project it onto a mechanical substrate without the field generators interfering with the blade's molecular structure? For the next 3 hours, we worked through the technical challenges. I provided specifications for quantum field projection. Yuki offered insights into molecular bonding characteristics. Miles suggested using harmonic resonance to sync the field with the blade's atomic lattice. Raj built and rebuilt components as we refined the design. It was chaotic. People talked over each other. Ideas were proposed, rejected, modified, and reintroduced. Equipment was assembled, tested, disassembled, and rebuilt differently. Nothing proceeded in logical linear fashion. And yet, somehow, we made progress. Field generator is calibrated, I announced, checking my instruments. Quantum coherence is stable. We're ready for initial testing. Martinez had joined us in the laboratory, observing from a safe distance. What's the failure mode if this doesn't work? Catastrophic molecular disruption of the blade, I said. Possible quantum cascade affecting nearby matter. Estimated damage radius of 3 meters. So, standard Tuesday in an experimental lab? Miles said, apparently serious. You regularly experience catastrophic equipment failures? I asked, alarmed. Define regularly, Raj replied, which was not reassuring. Yuki activated the containment field around the testing area. Shields are up, Consultant Krell. Whenever you're ready. I initiated the quantum field generator. Energy readings spiked as exotic particles flooded the containment area, surrounding the diamond blade with a shimmer of probability distortion. The blade began to resonate at frequencies that made my sensors recalibrate continuously. Field is stable, I reported. Blade integrity holding. Quantum effects are syncing with the molecular structure. Bring up the test material, Yuki instructed. Raj positioned a sample of complex polymer compound in the path of the blade. This wasn't the simple molecular chain from yesterday. This was a 3-dimensional lattice of carbon, hydrogen, oxygen, and nitrogen atoms, bonded in patterns that created extraordinary strength. Standard cutting would require breaking thousands of bonds simultaneously, I explained. The energy release would vaporize the material. But with quantum selective disruption, I activated the blade's positioning system. It moved forward at speeds measured in nanometers per second, touching the polymer lattice. And the material separated. Not cut, not broken. Separated. Individual molecular bonds dissolved as the blade passed, the atoms peacefully drifting apart and immediately rebonding behind the blade in whatever configuration we specified. Oh my, Yuki whispered, watching the molecular display. "Oh my! Is it supposed to do that?" Martinez asked. I said honestly. "This exceeds theoretical predictions by 17 orders of magnitude. The precision is impossible." "Looks pretty possible from here," Miles observed, grinning. We spent the next hour testing the blade on various materials. Complex polymers, metallic alloys, ceramic composites, even a sample of biological tissue. Every substance separated cleanly, precisely, with zero collateral damage to surrounding molecules. "Do you understand what this means?" Yuki's hands trembled as she examined the results. "We can perform surgery at the molecular level. Edit genes without damaging the surrounding chromosome. Remove toxic molecules from living cells. Repair nerve damage by reconnecting individual axons. Or manufacture materials that currently can't exist," Miles added. "Separate isotopes for fusion fuel. Purify compounds to impossible standards. Build computer processors atom by atom. Or dismantle waste products back to base elements," Raj suggested. "Perfect recycling. Zero pollution." My logic processors struggled to encompass the implications. This single breakthrough could transform both our civilizations, and it only existed because we combined incompatible approaches. "The Collective Council needs to see this immediately," I said. "Agreed." Martinez pulled up a communication interface. "But first, we should probably test it more thoroughly. Make sure the effects are stable and reproducible." For the next 6 days, we ran experiments continuously. The human crew worked in shifts, but someone was always in the laboratory. I didn't require sleep, so I remained present throughout, coordinating with different team members as they rotated through. I learned things during those days, important things that weren't in any technical manual. I learned that Miles told terrible jokes while working, claiming it helped him think. His puns about molecular bonding were objectively awful, yet somehow they did seem to correlate with creative problem-solving. I learned that Raj worked best late at night when the ship was quiet, his hands moving with meditative precision as he crafted components too delicate for standard fabrication equipment. I learned that Yuki became ferociously focused during critical experiments, often forgetting to eat or rest until someone physically removed her from the laboratory. And I learned that Martinez possessed an extraordinary ability to see connections between disparate concepts, often suggesting combinations that seemed illogical but proved remarkably effective. These were not things my evaluation protocols were designed to measure. Efficiency ratings and technical specifications captured none of this essential humanity. On the 7th day, we prepared our presentation for the Collective Council. Martinez had insisted on including not just the technical data, but also the collaborative process. She wanted to show how we worked together, not merely what we produced. "They won't care about interpersonal dynamics," I argued. "The Council evaluates results, not methods." "Then maybe it's time they learn to care about methods," Martinez replied. "Because the method is what makes this sustainable. Anyone can have one breakthrough. Building a framework for continuous collaborative innovation? That's the real achievement." The Council convened via quantum link, their projected forms appearing in our conference chamber. 12 members, representing the major species of the Collective, their expressions uniformly skeptical. Council Prime Thex 9 spoke first, her synthesized voice carrying obvious doubt. Consultant Krell 5. "Your preliminary reports have been reviewed. You claim the humans possess technology that rivals or exceeds collective capabilities?" "Not rivals, Council Prime. Complements." I activated the presentation, displaying our experimental results. Human engineering approaches problems from fundamentally different perspectives. When combined with collective precision, the results exceed what either civilization could achieve independently. I walked them through the quantum blade experiments, showing the molecular separation footage, the precision measurements, the material analysis. The Council members' skepticism gradually transformed into interest. This is significant, acknowledged Council Member Vorn 1-2, a being whose species specialized in material science. If reproducible, the applications are extensive. We have reproduced the results in 47 separate experiments, I confirmed. Success rate is 93%, with failures attributed to calibration errors that are easily corrected. What resources does this technology require? Asked Council Member List 3, ever focused on efficiency metrics. Surprisingly minimal, Yuki interjected, stepping forward. The quantum field generators are collective technology you already possess. The diamond blades we manufacture at a fraction of the cost of your quantum scalpels. The real resource requirement is cross-species collaboration. Elaborate, Vaxon commanded. Martinez took over. This breakthrough happened because we combined different knowledge bases and problem-solving methods. Collective precision with human adaptability. Your computational modeling with our intuitive experimentation. Neither approach alone would have succeeded. You're proposing permanent integration of human methods into collective research protocols? Vorn 1-2 sounded uncertain. We're proposing mutual exchange, Martinez corrected. You teach us your energy manipulation and quantum physics. We teach you our flexible manufacturing and adaptive engineering. We work together on projects that benefit both civilizations. The council members conferred privately, their quantum link creating a localized communication bubble. I waited, surprised to find myself hoping they would approve. Somewhere during the past 7 days, my mission parameters had shifted from evaluation to advocacy. Vaxon reactivated the public channel. The Council has concerns about introducing human unpredictability into collective research environments. My response bypassed my diplomatic filters. With respect, Council Prime, predictability is why we've had only 3 major technological breakthroughs in the last century. The humans generate innovations constantly because they embrace experimental failure as a learning tool. The silence from the Council was profound. Consultants did not contradict Prime Counselors. You have been compromised by prolonged human contact, Vaxon said flatly. I have been educated by it, I replied. I arrived on the meridian sky, certain of collective superiority. I leave, recognizing that superiority in one area does not mean superiority in all areas. The humans excel where we struggle. We excel where they struggle. Collaboration allows both species to transcend our individual limitations. More private conferencing. Then Kowalski spoke up, his aged voice carrying quiet authority. Council members, I spent a decade working with the collective embassy. I have enormous respect for your achievements, but I also noticed your civilization has become risk-averse. Every decision must be simulated, analyzed, and approved through multiple layers of bureaucracy. You've optimized for stability at the cost of innovation. He gestured around the Meridian Skies conference room. Humans are messy and chaotic and inefficient, but we're also flexible and creative and persistent. We try things that might not work because sometimes they do work. And when they do, they work spectacularly. You're asking us to embrace chaos, List 3 said, making it sound like a terminal diagnosis. We're asking you to embrace possibility, Yuki corrected. Controlled chaos, if you prefer. Experimental spaces where failure is acceptable and unexpected results are celebrated rather than suppressed. The Council's deliberation stretched for 20 minutes. I used the time to review my logs from the past 7 days, examining how my own certainty had gradually eroded and rebuilt into something more nuanced. Finally, Vaxon returned. The Council has reached a decision. We approve a 5-year pilot program. 3 joint research facilities will be established, staffed by both collective and human personnel. Projects will be selected that benefit from combined technological approaches. Relief washed through my circuits, an emotional response I hadn't experienced before. However, Vaxon continued. This program requires oversight from someone who understands both civilizations. Consultant Krell 5. You are hereby appointed Director of Collaborative Innovation. You will split your time between collective and human facilities, ensuring proper integration of both methodologies. I felt my processors freeze momentarily. Council Prime. I am not qualified for such a position. I have no experience with long-term human interaction beyond this single evaluation, which makes you uniquely qualified, Vaxon replied. You have directly experienced the transformation from skepticism to understanding. You can guide others through that same process. Unless you wish to decline the appointment? I looked at the humans around me. Martinez was smiling. Yuki gave an encouraging nod. Miles offered a thumbs-up gesture I had learned meant approval. Raj simply grinned. I accept, I said. The council disconnected, leaving us in the conference room. For a moment, nobody spoke. Then Martinez started laughing, and the sound was infectious enough that the other humans joined in. What is humorous? I asked, confused. You showed up here thinking we were primitive, Miles said, between laughs. Now you're stuck working with us for 5 years. I do not feel stuck, I said, and realized it was true. I feel curious about what other surprises you might have waiting. Oh, plenty, Raj assured me. Wait until you see our spacecraft repair methods. We use duct tape. What is duct tape? An adhesive fabric strip that holds anything together temporarily, Yuki explained. Or permanently, depending on how much you use. My logic processors recoiled in horror. You repair spacecraft with fabric adhesive? Among other things, Kowalski said, still chuckling. Welcome to Human Engineering, Director Krell. We're going to teach you the fine art of making things work, despite violating every sensible design principle. Over the following months, I split my time between the Meridian Sky and the newly established joint research facilities. The first breakthrough came from a team combining collective energy containment with human mechanical engineering, creating a fusion reactor that could operate safely without exotic matter stabilization. Cheaper, simpler, more reliable. The second breakthrough involved human medical techniques integrated with collective nanotechnology. Surgical procedures that had required months of recovery could now be performed in hours with minimal trauma. The third breakthrough was more subtle, but perhaps most important. A young collective engineer named Pix-7 spent 3 months working alongside a human machinist named Elena Volkov. Pix-7 returned to the collective and immediately began advocating for revised research protocols that allowed controlled experimentation without requiring pre-approval for every step. The changes were spreading, not rapidly, but steadily. Like water seeping through stone, human flexibility was infiltrating collective rigidity, while collective precision was refining human chaos. I stood in Laboratory 7 aboard the Meridian Sky, watching a new team of mixed-species researchers calibrating equipment for yet another experimental collaboration. They argued and laughed and problem-solved together, species differences becoming increasingly irrelevant. Martinez appeared beside me, observing the same scene. Thinking deep thoughts, Director? Acknowledging that I was incorrect, I said. When I arrived, I believed the collective had nothing to learn from humanity. I was profoundly wrong. And we've learned plenty from you, Martinez replied. Those quantum simulation tools have already improved our ship designs by 40%. Turns out modeling things before building them isn't such a bad idea. Revolutionary concept, I said, and was pleased when Martinez recognized the sarcasm. She laughed and placed her hand on what passed for my shoulder assembly. I no longer found the gesture unsanitary. Touch was how humans communicated trust and camaraderie. I was learning their language, even as they learned mine. So, what's next for our favorite collective consultant turned collaborative innovation director? Martinez asked. I pulled up my project list, displaying dozens of pending proposals. There is a collective mining operation that could benefit from human explosive engineering. A human agricultural station that needs collective weather control systems. A joint planetary survey that requires combining long-range sensors with atmospheric sampling butterflies. Sounds like you'll be busy. Constantly, I agreed. It is inefficient, chaotic, and unpredictable. And I find I am looking forward to it. The humans have taught me something the collective forgot. Perfection is static. Growth requires imperfection, experimentation, and the willingness to be wrong. Pretty philosophical for a logic-based artificial intelligence, Martinez observed. I contain multitudes, I replied, borrowing a human phrase I had learned. From Miles. Martinez smiled. Yes, Director Krell, I believe you do. As I watched the mixed species team achieve a successful calibration and celebrate with an inefficient but emotionally satisfying group cheer, I realized the most profound discovery wasn't technological at all. It was the recognition that advancement doesn't come from one species, one method, or one way of thinking. It comes from the collision of different ideas, the friction of incompatible approaches, and the synthesis of opposing philosophies. The humans hadn't just shown me new technologies, they had shown me new possibilities for what civilization could become when it embraced both order and chaos, both precision and adaptability, both certainty and wonder. And perhaps most surprisingly, I had discovered that even a logic-based collective consultant could learn to appreciate the beautiful inefficiency of collaboration, even if they still used duct tape to repair spacecraft. Some mysteries, I suspected, would take more than 5 years to understand.